My name is Uwe Friedrichsen and I work for a company called Codecentric. It's a German-based company. We're doing software development and consulting basically, and my specific role in there is, the job title is CTO, but I'm also still working a bit as a consultant. I'm doing conference talks and I'm actually doing CTO work. The problem is that these days, due to the effects of digital transformation, which means that software is everywhere basically, and that we need to have software always up and running, resilience becomes more and more important. And it has several facets basically. The one of the facets is its robustness of the software, that it's able to deal with expected kinds of failures or failure modes, so that it either can prevent them or quickly recover from them or mitigate them at least, and then when situations better, then completely recover from them. And on the other hand, which is quite often forgotten, but which I'm also talking about, is that we also need to be able to deal with surprises basically. So failure modes that we didn't expect, that we didn't plan for, that we didn't write any code for, and therefore we also have to set up our organization in a way that if a surprise happens, that we have the capacity basically and the skill and the knowledge and the training to be able to quickly respond to that. And in the very, very, very best case, that we're even improving from this failure situation so that we are better off afterwards than we were before, so which is called anti-fragility. So, and these are different levels. Most of the time I'm talking about the technical resilience, so making systems more robust, but I'm also talking about these other things. It's really challenging to integrate this topic of resilience into the way we are developing software these days with rapidly changing requirements and all these things, and always trying to be as efficient as possible. So getting as much done with as little time as possible, which also means that on the other hand, the organization doesn't have the slack anymore to respond to surprises, which by the way is the most tricky part to get done in resilience. So sometimes you still get the time to build these failure management measures into your system design, saying, okay, we've got a timeout here, we've got a retry over there, we have a fallback implemented in this other place, and so on. But latest when it comes to the organization, in that moment, quite often people say, yeah, we don't have the money for that, so because we have to utilize Presel for 100%, because otherwise it's too expensive, and all these things, and which makes the discussions to integrate resilience into the daily business quite hard. On the other hand, is it that companies experience ever more business and technical problems with surprises actually, unexpected events in their business and also in their IT, and they need to be able to respond to that. So we have some tension in here, and I think over time the tension will go away a little bit from efficiency over more to resilience, because that's required for long-term viability. When we talk about software development, or if we also talk about organizations as a whole, we often have this term efficiency in here. Efficiency is the ability to do things right, basically. So the simple way of phrasing is doing the thing right. So doing it without waste, doing it a good way, and so on. And efficiency is useful. And unfortunately, we are so focused on efficiency that we often forget effectiveness. Often confused, by the way, by people saying, oh, well, what's the difference between efficiency and effectiveness? But it is fundamentally different, because effectiveness is the ability to do the right thing. So to do something that actually in the end creates value. And we are very often so much focused on doing things more cost efficiently with less resources and so on, that we forget to ask ourselves, are we doing the right thing? And what I'm seeing in IT is that we are wasting tons of time, money, and often also health of people in trying to become more and more efficient, without actually doing the right thing, so without creating any value. So basically what you see, for instance, from figures from feature usage. So if you implement some kind of business feature in your IT systems and then release that stuff and you measure how often it's used, then quite often, so the companies that are still measuring, they figure out that about 20% of their features are used. So 80% of the whole efforts they spend is waste. And usually if you do not measure, you're even worse. So usually about 90% of what you're doing is just waste. And you're doing the waste more and more efficiently because you're not creating any effect. You're not effective. And this is a whole area of tension where we can improve such a lot. And that's why I'm talking about that too. And we have another topic which is in the room, which is basically sustainability, ecological sustainability. Just to be clear, sustainability has several aspects. We have economic sustainability, we have social, human sustainability, we have the ecological sustainability, and we have the technical sustainability, which we all have to take care about. But right now, this aspect of the ecological sustainability comes more and more into focus. And if we just ponder how much efforts we're wasting and how much we're wasting in terms of running IT systems for nothing, then I find it very interesting to ponder the idea of sustainability, of course, to make IT greener in the end. But it also creates a very nice counterforce, which affects the whole software development process, because usually our typical reaction is, oh, we need some availability, so let's add some more machines to it, so redundancy. Oh, we need better response time, so just let's add some more CPU to it, because tuning the code would be it's cheaper to add more CPU to it than tuning the code or anything like that. If you now take sustainability into the picture, you get a counterforce, and now it becomes interesting. So the one side says, hey, can we have more? And the other side says, well, can we have a little bit less? And you have to balance these two ideas. And that's why I hope sustainability becomes an even bigger issue the next years, because it brings us back from this more to, hey, reasonable. If we talk about sustainability, AI, and especially generative AI, GenAI, is of course one of the topics that immediately comes to mind. So these huge models that cost tons of resources of energy to train, to run, so to produce the hardware for it, to run the stuff, and so on. And some of the cloud providers who wanted to be green within a few years just increased their CO2 footprint by 600% the last year or something like that, which is not exactly the way to becoming green. Yeah, and so I'm torn a little bit, to be honest, if it comes to GenAI. On the one hand, it's really useful. It helps us to accelerate tasks that are often not too productive. So like figuring out, searching in a lot of places and then trying to bring that all together and so on. Or there are a lot of places where it's useful. On the other hand, it's a huge waste of resources. And if I just brainlessly use GenAI to, hey, look what a cool picture I just did here with solution X, Y, or Z or something like that, I'm always sitting there saying, well, you want to have a planet for the next 50 years and you're just creating mindlessly pictures because it's funny. Maybe we find a middle way. Again, counterforces. So we need to balance these things. I think GenAI has a place, and AI most definitely has a place, not only GenAI, but AI has a place. But we have to balance this with a lot of other forces. This is architectural thinking, basically saying, okay, we have a lot of forces, and we trying to find a good balance between these forces, that in the end, the system that we create makes sense in some way, in multiple ways, actually. If we think about all these challenges we have these days, the question is, how can we achieve all that? I'm not sure if there's a perfect plan for it, but basically we have a lot of the building blocks in place. So we have in place a lot of foundations of robust software design, how to do this. From our domain, but also from other domains, we can learn a lot. Also about resilience. We know how to create solutions which are energy efficient, but we still have the problem at the moment that compute resources are a lot cheaper than human resources, if we want to call them resources. I do dislike that term a little bit, not just a little bit. And therefore, usually it says, okay, do not spend your time on creating a good solution. We are buying more compute capacity for that if it takes more resources. So what? The next generation of CPUs will manage that too. I think another good lever in this place would be simplification in some way. So how can we create simpler solutions that do the same job but do not require as much energy? And also especially sitting there and then asking yourself the question, do I really need that? I mean, we have this Yagni in IT, you ain't gonna need it. So don't do it if you don't really need it. And we have it in coding quite a lot, this Yagni. In architecture and system design, we don't have it that often. So we are still pleased with us creating huge, overly complex designs and saying, no, why don't we simply create the smallest design possible, solution possible to do the job? And maybe with that solution, we also can reduce our footprint. And because it's simpler, it's easier to understand. So you do not create these many errors and bugs in the solution, which gives us a higher robustness. So basically it's all intertwined. So simplification and effectiveness and resilience and sustainability, they add up to each other in some way. But it would be a bit more of a deep dive to really go into the details then. The first point to start with as your software architect is understanding your domain. What makes sense, what does not make sense, why are they doing things and so on. Because this allows you to ask the questions. You have this requirement. Do you really need that in this way? Because it's a lot of effort to implement that. So is it really creating this big business value, or do we find different ways to do things? After we have that in place, so we're having good requirements. Now it's about a good design. And the problem that I see is that we're still lacking the foundations of good design. So in the early 70s, some very smart people who were a lot smarter than I am, came up with the ideas of high cohesion, low coupling, with separation of concerns, and with information hiding. And these three are the basic building blocks of good software design. So everything we've learned after that is basically just built on top of these three foundations. The problem we're having is that you still haven't really understood how to implement these three foundations properly. You see that all the time if you see system designs which are not really loosely coupled, if you see API design which doesn't do good information hiding and so on. And then I see a lot of people walking around saying, yes, I do domain-driven design. And domain-driven design is a really good idea to have in mind if it comes to software design. The problem is, if you haven't understood how to do high cohesion, low coupling, separation of concerns, and information hiding, it doesn't help you a bit, because everything in the domain-driven design builds on these three foundations. It's just a composition on top of that. And if the foundations do not work, the rest is useless too. And maybe a little bit of empathy, because we have to discuss with a lot of people. Architects often think, we do the decisions, we make the decisions. We don't. We don't make decisions. Other people do. Managers make decisions. Business experts make decisions. Developers make decisions. Ever try to make a developer implement your architectural design if they don't like it? They're very creative people, and they will use all their creativity to not implement your architecture. So if you have people and you need to discuss with them, you have to convince them. And it's very important for convincing people to be able, and that's empathy basically, to understand their point of view. Why are they acting the way they're doing? What are their pains? What are their concerns? What are their needs, their demands they're having? Not to confuse it with sympathy, because it's okay if you dislike it, but as soon as you understand it, you're able to have a very different conversation with the people. And if you're also able to level up this kind of communication skill and empathy, I think you have a good basis to get started.